In this example, we are tasked with multiplying and dividing inside of the same expression. That will not change our work at all, provided that we are careful with each one of the operations, working our way left to right. This division symbol only appears in front of the last of the fractions, meaning that that fraction is the one that we will engage and move to its reciprocal. The other two will stay the way they are, factored as they are, and we'll simplify as best we can, given all of the factors from each of the fractions. So looking at each one of these 6 pieces one at a time. In this first numerator, we see a common factor of b, leaving behind an a squared plus 1. In the denominator, we might want to engage the AC method or use a little bit of trial and error, but we can get a factorization there of 3a minus 10 and a plus 2. Moving to the second fraction, no need for a reciprocal here. We'll just engage in the same practice. Again, a greatest common factor of a, similar to the last numerator. And then in the denominator, this one's a little bit easier to engage with trial and error, but we have 2a plus 1 and a plus 5. The fact that that was a 2 and that was a 5 and that was an 11 means that I probably want to set this up so that the 2 and the 5 would get multiplied together. That would get me pretty close to that 11 as that middle term. Moving to the last one, this is where we're going to see our multiplication. Now, we had been writing that division as a separate factored line. You can do that, or you could do it all in one move. We changed this to multiplication. I know that ab squared is now going to be my denominator, and then my numerator is going to be the factored form of this trinomial. Again, AC method, trial and error, but there's a pretty good hint somewhere else in the problem. Notice that this 6 could be factored as 6 and 1 or 3 and 2. The fact that there is a 3 and then there's a 3 down here, way over here on the left, is a pretty good indication that a good place to start guessing would be with 3a minus 10. And that actually is the correct factor along with the 2a plus 1. You see that factor as part of the denominator here. We see that factor as part of the denominator in the middle. We notice the very obvious a plus 5 division. We have this extra a here, simplified with that a there. And we have a b from this numerator, simplifying with one of the b's from that denominator. There's a lot of simplifying that has to take place, and just as we would do normally with multiplication of fractions, this is just cross-simplifying. This is taking factors from one fraction, numerator or denominator, and canceling it with somewhere else. So you have that ability to jump around, which is a nice convenience. You're not left with such a large expression with so many factors. So looking at our numerator, what do we have left? We have a squared plus 1. And then looking at our denominator, what do we have left? We have a plus 2, and then this 1 left over b. Many students have a hard time keeping track of individual terms that are canceled and or simplified. That's certainly understandable. You can see that this can get kind of gross as you go longer and longer through the problem with all the crossing out. Consider using a different color. Consider using some kind of pen or highlighter to highlight those factors that are still available. Use some technique that makes sense to you to keep track of all of the different terms. I prefer using a separate color. Didn't do it here. I prefer using a separate color and then using some other color to highlight those terms that are still remaining. In our last example, we have a set of parentheses necessitating that we do the second division first. So we're going to leave a minus b 4c division all the same, and we're going to operate like the inside of this parentheses is the only question that we are answering. We'll leave our first fraction the same, and we'll use this reciprocal of the second fraction. We have opposites of each other in the b minus a minus b. So we'll simplify those two and leave behind a negative 1. We lose this c from the denominator of the first fraction with one of the c's from the second fraction. And all we're left with here is this negative 1 that came from canceling the opposites and one of these c's. Meaning our next line leaving all of the parts outside of the parentheses the same, all we have left from this inner part is negative c. Knowing that negative c is really negative c over 1, we engage the reciprocal one more time, and there's nothing else to be done. I moved this c to the denominator. I cannot go across to do my simplification. I have to go diagonal. So my only option at this point is to just piece these two together. I've got negative a minus b and my denominator of 4c squared. This is a perfectly appropriate answer. However, you will see some people who will write this answer without this negative sign out there, running the negative sign into that parentheses, using the distributive property. The a would switch to negative, the b would switch to positive, and you have a final answer of b minus a over 4c squared. You can decide which one of those two you like more as an answer. There are some people who say, hey, I got all the pieces together, everybody fit together, that's my answer. And then there's some people who say, we want our answer to be as simple as possible, remove any extra signs, we don't need it. That's also perfectly fine. Whichever strategy and whatever representation makes the most sense to you is the one that you should use.